Hi guys! So we've been learning about some rules for derivatives, and so far we've learned a bunch of different stuff that we can do. Today we're going to take those rules about derivatives and tangent lines and slopes, and we're going to use them to answer slightly more complicated questions. So these questions are very similar to the types of things they might ask you on an AP test. For example, does this curve, y equals x to the fourth minus 2x squared plus 2, have any horizontal tangent lines? What we need to realize here is that when we see horizontal tangent lines, that means places where the derivative equals 0. Just as a side note so that you can remember why that works, you're only going to have a horizontal tangent line when you're at the very top of a hill or at the very bottom of a valley. Those would be places where the slope is 0, because horizontal lines have a slope of 0. So if I want to figure out if I have any of these and where they might occur, the first step is take the derivative. The derivative would be 4x cubed minus 4x. The second step is make that derivative equal to 0 and solve the equation. So 4x cubed minus 4x equals 0. If I factor that, I get 4x parentheses x squared minus 1 equals 0. And if I continue and I factor it completely, I get 4x times x plus 1 times x minus 1 equals 0. So my three values would be 0, -1, and 1. So, do we have any horizontal tangent lines? Y has horizontal tangents at x equals 0, -1, and 1 because y prime equals 0. When it says justify your answer, please keep in mind you always need to justify it using mathematical terminology. So saying y prime equals 0 is the math reason why this would be true. All right, in problem number 2, as can be seen in this viewing window, this graph has 3 horizontal tangents. Where do they occur? Justify your answer. If we graph this on our calculator, because they are referring to a graphing calculator with like a viewing window, if we were to graph this function on our calculator, we would have 0.2x to the fourth minus 0.7x to the third minus 2x squared plus 5x plus 4. I'm going to zoom 6 because zoom 6 is the standard viewing window. It's from -10 to 10 in the x direction. It's also from -10 to 10 in the y direction. Looking at this picture, it's obvious that they're correct. There are 1, 2, 3 places where horizontal tangents would occur. In addition to thinking about horizontal tangents occurring at places where the derivative equals 0, we can also think about this at being at places where there is a max or a min on the graph. So using our graphing calculator, we can calculate by going to second calculate the maximum or the minimum. I'm going to find the minimum first, which is option 3. I'm going to use my little left and right arrows until I move to the left of this lowest point. Doesn't matter how far left, just slightly left. I'm going to hit enter. Then it says right bound, so I'm going to move my arrows till I get slightly to the right of that lowest point, and I'm going to hit enter again. And then it says guess, so I'm going to hit enter again. The minimum here would be when x is -1.862. -1.862. If I want to find the next value at the very top of this hill, I would go to second calculate. Maximum is option 4. It says left bound, so I want to make sure my little blinky guy is slightly to the left of that maximum, and I'm going to hit enter. Then right bound, I want to make sure my little blinky guy is slightly to the right and hit enter. Then guess, hit enter again. I should get 0.948 as my next value. Last but not least, I would go to second calculate. The last one is a minimum. I'm going to move over till I'm slightly to the left of that minimum and hit enter. Slightly to the right of the minimum, hit enter. Enter one more time for a guess. I would get 3.53. Now again, justify your answer. So my justification would be because y has max or min values. Anytime you have the top of a mountain or the bottom of a valley, it's going to be a horizontal tangent line. So horizontal tangents are, again, one situation in which we can use our idea of derivatives and how derivatives and slopes work to answer more complex questions. The next type of question the AP test loves to ask you is rules questions. I call this a rules question because it's going to make you use the rules for derivatives without actually taking a derivative. So, it says here the regular x value of 2, if you take a 2 and you plug it into u's function, you get 7. If you take a 2 and you plug it into the derivative of u, you get negative 5. If you take a 2 and you plug it into v, you get 2. And if you take a 2 and plug it into v prime, the derivative, you get 3. It says find y prime, so find the derivative at 2 for each of the following functions. And each of these functions is defined in terms of u and v. To find the derivative of the first function, first I would need to actually find the derivative. Because u is being multiplied by v here, I would use my product rule. Keep the first one the same, take the derivative of the second. Plus, keep the second one the same, take the derivative of the first. Now I want to know these specific values at 2. So if I take a 2 and I plug it into u, based on this problem, it's a 7. If I take a 2 and I plug it into v prime, based on this information, it's a 3. If I take a 2 and I plug it into v, based on this information, it's a 2. And if I take a 2 and I plug it into u prime, based on this information, it's a negative 5. So I would get 21 minus 10, which is 11. This problem allows me to see that you know product rule without actually having to do derivatives. So it's isolating product rule from other derivative rules. For part B, first I would need to take the derivative. So the rule for division is low d high minus high d low, and low squared goes down below. Low would be v, derivative of u, minus high would be u, derivative of v, v squared goes down below. Now I'm going to plug in my numbers. If I plug a 2 into regular v, I get 2. If I plug a 2 into u prime, I get negative 5. Minus, if I plug a 2 into u, I get 7. If I plug a 2 into v prime, I get 3. Last but not least, if I plug a 2 into regular v, I get 2. So we're going to have negative 10 minus 21 divided by 4, which is negative 31 divided by 4, and that would be my rule. Again, I know that you can do division, the quotient rule, without having to know other derivative rules at the same time. Last but not least, if we take a division problem and we flip it over, does that or does that not change the result? So if we use that same rule, low d high minus high d low, and low squared goes down below. Based on that alone, I can tell it's going to change the result at least a little bit because the numbers are going to be in different orders. So I would have, if I plug in my numbers, plug 2 into regular u, I get 7. Into v prime, I get 3. Minus regular v, I get 2. U prime, I get negative 5. And at the very bottom, for regular u, I get 7. So I get 21 plus 10, because 2 negatives make a positive, over 49, which is 31 over 49. Again, is this different? Absolutely. Order matters, especially in division and subtraction. Sorry, you couldn't see all the way to the edge of the paper there. Let me move that over a little bit. Okay, next. Write an equation for the line that is tangent to this curve at that point. Tangent line. We know we need two things. We need a point and we need a slope. The point is given to us, 1, 2. To figure out the slope, we better take the derivative. Again, low, d high, so 2x, d high, so 2x again, minus high, which is x squared plus 3, d low, which is 2, and low squared goes down below, 2x quantity squared. If I simplify this, I get 4x squared minus 2x squared minus 6. I'm distributing the negative and the 2 to both the x squared and the 3. All over 4x squared. If I plug in the x value that I know, I have 4 times 1 squared minus 2 times 1 squared minus 6, all over 4 times 1 squared. So 4 minus 2 minus 6, all over 4. 4 minus 2 will be 2, minus 6 is negative 4 over 4, which is negative 1. So my slope is negative 1, which means my tangent line would be y minus 2 equals negative 1. You can't see what I'm writing. There we go. I fixed it. Negative 1 parentheses x minus 1. Give you a second to finish copying that. If you have any questions, you can look back over it again. Now, number 5 is another tangent line question. So again, they're asking me to write the equation of the tangent line. The difference here is that instead of telling me the ordered pair, they only gave me the x value. We still need a point and a slope. The x coordinate of our point is a negative 3, but to figure out the y, I need to take the negative 3 and plug it into the original problem, not the derivative, the original. I would have 9 minus 6, which is 3, plus 1 is 4. Now I need the derivative, so f prime of x, which is 2x plus 2, and I can take my negative 3 and plug it in there, which is negative 6 plus 2, which is negative 4, which means my tangent line would be y minus 4 equals negative 4 times x plus 3. The only difference is that we didn't know the y here, so don't forget that to get the y, you use the original function. Okay. There's one more example that we can do that will talk about applications of derivatives. So suppose that the amount of water in a tank is given by this function, where this is the volume. That's why they're using the letter V. Determine the following, justify your answers. Is the volume increasing or decreasing? When I hear increasing, I'm thinking, is it changing by going up or changing by going down? To figure that out, we need to look at the rate of change, which is the derivative. So I would do the derivative of my volume, which is 4t minus 16. They are specifically asking about what's happening at 1. So it'd have 4 times 1 minus 16, which is negative 12. Since the rate is negative, we would have decreasing. If the rate was positive, we would have increasing. So is the volume increasing or decreasing at 5? Using that same derivative formula that we had in part A, if we plug in the number 5, and again we're using the derivative because this is the rate of change, we would have 20 minus 16, which is 4. Therefore, since this is positive, we would say that our amount is increasing. Is the volume of the water changing faster at 1 or 5 minutes? So we've already know what's happening at 1 and 5, but which one's changing faster? Now it didn't specify here, is it changing faster by increasing or changing faster by decreasing? Because this one is decreasing at a really fast rate, negative 12, versus this one increasing really slowly, 4, we would say we're changing faster at t equals 1 because negative 12 is a faster number even though the amount is going down. Last but not least, part D is the volume of the water ever not changing. Not changing means the derivative equals 0. It's not changing. So, is the derivative, which we've already calculated, ever equal to 0? Well, if I solve this, I have 4t equals 16, so t equals 4. Is it ever not changing? Yes. It is not changing at t equals 4 because v prime is equal to 0 at that number. Okay, that's it for today, and I will see you tomorrow.